decimal expansions of real numbers. We can classify real numbers as rational numbers and irrational numbers. These are examples of rational numbers where we can write p, the number in p upon q form, where p and q are integers and number in denominator is other than 0. Rational numbers can have terminating decimal expansions or non-terminating and recurring. These are examples of rational numbers, and these are respectively their decimal expansions. 7 upon 5, when we divide 7 by 5, we at one step we get remainder 0. So such decimal expansions are called as terminating. And when we try to divide 1 by 3, the remainder never becomes 0. So we called this as a non-terminating, and we get 3 again and again in quotient part. So we call this decimal expansion as non-terminating and recurring. These are dots at the end of decimal number tells us that this is non-terminating, and this number of threes can be written by that recurring group and a bar on that numbers. Irrational numbers. These are examples of irrational numbers. Decimal expansions of irrational numbers are non-terminating and non-recurring. This is non-terminating and no specific pattern is repeated, so it is non-recurring. This is decimal expansion of root 2. There are infinitely many rational and irrational numbers between any two given rational or irrational number. Let us see how we can find out such numbers. Find 6 rational numbers between 3 and 4. 3 and 4 are two consecutive natural numbers or whole numbers or integers. We have to find out 6 rational number between them. The one method is add these numbers and divide that interval by 2 to get the number in between 3 and 4. Then consider this 3 and 7 by 2, add these numbers by making their denominators equal, and then divide that by 2 to get another rational number between these two numbers. But the simplest method is write the equivalent fractions of 3 and 4. These can be written as 30 upon 10 and 40 upon 10. Value of 30 upon 10 is 3 and 40 upon 10 is 4. Now 6 rational numbers between these two can be 31 upon 10, 32 upon 10, 37 upon 10, 38 upon 10 and 39 upon 10, and I can write this as 33 upon 10 also. So your numerators can be any number between 39 and 31 to 39, and denominator will be 10. Find 5 rational numbers between 3 by 5 and 4 by 5. Now these are two rational numbers, and let us write down their equivalent fractions. These equivalent fractions can be 30 upon 50 and 40 upon 50. Similar to previous question, we can write numerators from 31 to 39. So the 5 rational numbers, required 5 rational numbers are 31 divided by 50, 32 divided by 50, 34 divided by 50, 36 divided by 50, 39 divided by 50. Find 3 rational numbers between 0.1 and 0.11. These are rational numbers, and Actually, there is nothing between these two numbers if we consider 1 and 2 decimal digits after decimal point. But we can write these numbers as 0.100 and 0.110. Now, from 0 to 10, any digits after 1 will give us the required rational numbers between given rational numbers. This can be 0.103, 0.105, 0.108. Find three different irrational numbers between the rational numbers. Now these are rational and we have to find out three different irrational numbers between these two. For that, first we have to find out decimal expansion of 5 upon 7. 5 upon 7. Now this will be a non-terminating and recurring decimal expansion, and that decimal expansion is 0.714285. This pattern will come again and again. Now let us find out decimal expansion of 9 upon 11. Decimal expansion of 9 upon 11 is 0.818181. So this can be written as 0.81 bar. These are two rational numbers and we have to find out irrational numbers between them. Now decimal expansions of irrational numbers are non-terminating and non-recurring. So consider any number between 0.71 and 0.82. Three different irrational numbers. Here we want to find out irrational numbers. In previous questions we have obtained rational numbers. Now consider any number between 0.71 to 0.81. So these numbers can be 0.7354442223. You can write any pattern of non-terminating and non-recurring numbers. Now two more, and they must be between 0.71 to 0.81. Let us consider 0.75, 755, 7555 and dot dot. Next can be 0.7712590000. So these are non-terminating and non-recurring. So these are decimal expansions of irrational number. Now these are some questions for practice. Find three irrational number between the given rational numbers and find some rational and irrational number between given pair of numbers.